I'm Larry Kenny of Larken Automation. It's April 5th, 2020, and the world's in a pretty bad state right now. And there's not enough ventilators in the world. And it isn't just a North American problem, it's a world problem that no one saw this coming. Well, actually they did, but no one did anything really, or didn't do enough. But anyway, what I've built here is a ventilator. You know, it's my idea of a ventilator, and the whole point of this is to be able to build a ventilator with very cheap parts. All it really is a stepper motor, a controller, and some type of cylinder to pump the air out. And you can see here, every time it goes up, it's bubbling, putting out air. And now, what I'm trying to do here is just show how you build one. If you're somewhere and a country doesn't have much money, but you might have some parts and you might have some ambitious people. And I actually built this in 4 days. I started building this on April 1st. It was Wednesday. I saw someone on the internet, on Facebook, say, how come nobody's building ventilators or something like that? So I went on YouTube and I looked at some designs, and they were basically taking an existing medical ventilator and squeezing it. And I mean, if you have the medical ventilator, where are you going to get those? So they're all taken up by the hospital. So this is made from scrap parts, and a lot of people that know stepper motors or automation could build something like this. What I got here is a beaker, a glass beaker, a Pyrex beaker. This is actually off a coffee, a French press coffee gadget that was lying around the house. So what I built here, now I'm lucky I have a machine shop and I have CNCs, and I've been doing this for 30 years. So I was able to do it pretty fast. Now, what I have here is I have a plastic piston, and I have reed valves. So there's a reed valve on the top and a reed valve on the bottom. So the air goes in here and comes out here. And every time it comes down, it breathes in more air through this side, reed valve, and then up. When it goes up, it goes out and goes here. Now, here I have just a simple valve arrangement, not a valve, but that's a pressure release. All it is a weight, and I mean, that could be improved upon. I built this thing in 4 days, so there's a lot that could be improved upon, and I'd welcome anybody's suggestion on how you could improve it with readily available parts. That's the key. You can't say, oh, well, I'm going to order a linear axis here and order it, because nobody's working right now, or very few people are, and you want to wait. We need ventilators right away. We can't wait. So it's basically very simple. It's an extrusion, 2 pieces of aluminum extrusion, a plate top and bottom, an actuator, and here I'm using a timing belt. The reason I'm using a timing belt is it quiets the stepper a lot. And also the timing belt can be any, there's lots of places you can get timing belts. You can get them off printers, you can get them off all kinds of stuff. So when you drive a stepper motor with a timing belt, it gets a lot quieter. And so I threw together a quick controller, and since I manufacture stepper drives and servo drives and CNC routers, I was able to do that. Now you can get all, this type of stepper motors and stepper motor drivers are quite plentiful in the world. But I have so I wrote my own processor here. So it's variable speed. Okay, so you can vary the speed. okay? And you can also vary the stroke. So you can see the lowest stroke it's got. Now this isn't really properly, okay, sorry, I turned the wrong knob here. Now if I, on the next, now it's coming down to here, on the next one, it's shorter. Now it's only coming down to here. So you can vary the stroke. Now I haven't really calibrated this because I wanted to get the video out, so the machine isn't quite perfect yet. There's a few little things I'm going to add. Like I'm going to add a stabilizer to this rod. All it is a plastic piece with a hole that sits on top of this just to stabilize it. Also something to keep it from turning. Just a vane out here with two bearings to keep this from turning as it goes up and down. So the controller varies the stroke and it varies the speed. Very simple. There doesn't even need to be a sensor at the top or a limit switch sensors, because that just adds extra things that can go wrong. So all it is the stepper motor drive is driving the motor, and there's a little computer board up here running a PIC processor, and it is generating the pulses, varying this, and letting you vary the speed and vary the length of the stroke back and forth. So also here, I'm in the process of hooking up a bunch of fail-safe systems, and so it'll be able to monitor its pressure just to make sure when the air goes out, it's seeing a normal pressure range, to make sure the hose isn't pinched or the hose didn't fall off and the patient isn't getting it. But so it'll be monitoring its pressure. I'm waiting on a sensor. I have a sensor in there, but it's not the right pressure range, so I'm waiting on a sensor from DigiKey. It'll also have a fail-safe system as well. It'll have a second board that is not connected to this board that monitors the pressure and watches the pressure going up and down within 1 to 2 seconds or 3 seconds, whatever. And if it doesn't see that pressure constantly going up and down, it sounds an alarm. And so it'll be a second little module, battery backed up. Now I'll probably have that done in 2 days. And but I'm just waiting on the sensor. So it'll be battery backed up, because if you have this board will have a sensor in it as well to monitor the pressure. So, but if the power failed on this and you didn't have a battery backed up secondary watchdog circuit, then it wouldn't know. So what you have, the way to do it is you have you have two circuits monitoring the pressure, but the second one will just be an analog circuit, a simple comparator circuit, and it's battery backed up. So if this fails, then the battery backed up circuit sees the pressure doesn't change, it sounds the alarm within 2 seconds. And so what I'm doing here is mostly sharing the technology to anyone around the world who thinks that these are hard to build. Now, but what I'm not supplying now, or what I'm not building, is the plastic hosing that goes to the patient, because I can't do that. So there must be someone else that can supply the plastic hose that goes down there into the windpipe and all that stuff, because that's not my forte. Now the valve that goes in their mouth, I'm not really sure. I've seen people 3D print them. I'm not sure how good that is, because 3D printing is porous and can leak, and you need a very good valve seal. When you have a flapper valve or a ball valve, you need a very good valve seal in order to seal. And a 3D printed is digital spots, so I don't know if that's going to work unless you printed it and then you machined the valve seat and then put it back on. Now I tried a couple different valves on this to get it right. I first tried a ball valve. I tried a ball valve system with marbles and spring-loaded marbles in the puck, in the cylinder, with this top thing on it, top cover on it, and but I found the at low pressures, ball valves take too much to get hysteresis to get them off their seating point, and it wasn't as good as a reed valve system. So there you can see the reed valve on the top. Actually, this piston is turning a bit, so I have to. That's why I have to make like a stabilizer. But you can see the reed valve in there on the top. So I've got a reed valve. I'll just stop it there. Okay. So I've got a reed valve on top of the piston, and I've got a reed valve below the piston. Now the one under below is covered by a little manifold cap. So the top one, the one that breathes in the air, now I didn't put a hose on here, actually I forgot, I should have put the hose on there for the demo, but it breathes in the air here and it puts out the air here as it goes up. Now this is just a 5/8 aluminum rod. This is just, I think these are 2 feet long extrusions. 3/8 plate. The glass jug is sitting in a plastic holder. Okay. Now I'll probably have to clamp it up here somehow with 2 little clips and springs from here to here, because if it's loose it might slide out. And but a medical beaker, like you want about a liter, from what I've heard you want about a liter, so a 1 liter beaker would also work. You might have to try out a few different ones to get one that's perfectly round or very close to round and not tapered. So this is about 3.5 inches in diameter. The piston on this is 3.55, I think it's inches in diameter. Now I've cut 2 O-ring grooves here, and it's possible it might need lubrication, and so that might be a sticking point, I don't know. But what I would do is I would put a little reservoir up here, and I would put vegetable oil in it, and it would have a hose, just a hose that hung and went up, drilled up into here, and then 1 hole across, so that the oil would come out between the O-rings. So it shouldn't get up here. So that will make it, because this machine has to run for days on end and not fail. That's why the simpler the better. I'm going to go around behind it. Now around behind, all you have is a stepper motor, and I have a bearing. That's a thrust bearing. That's a 5200 thrust bearing in a little block. And the shaft goes through and holds the top pulley. Now on the top pulley I've got a timing pulley, but it really only needs to be an idler, because you might not be able to get too many timing pulleys. But this is a 3mm pitch timing pulley, but you could also make it with a 5mm pitch or something in between to make it a little stronger, but this is all I had in stock. If you went with a 5mm pitch, you might want to increase the stepper size to a size 34, because if you go with a 5mm, the pulley is going to be a little bit bigger, so it's going to require more torque to move it up and down because the ratio is faster. So and what I did here is I just machined. I didn't have this part, so I just machined it. I have in a manual mill with a dial readout, and basically with a V cutter cut grooves 3mm apart right across. So this belt is cut. This belt is just it's not continuous. So this is just a piece of cut belt, and then they're clamped together by this little block here. And I have this shaft going through this this holder, and up top the 5/8 rod has two flats on each side that go into the bottom of the piston, and that way it can't turn on the piston. Now over here in the controller, what I've got is I've got a linear power supply, just a toroidal. It's running on about 45 volts. Okay, I've got my controller board up here running a PIC 18F processor. I think it's a 2431 or something. I forget. It's the same one I use on my Viper servo drive. So this board is actually half of a Viper servo drive. That's one of the products I make. But I just cut it off and used the processor side and programmed it for this. So here's a stepper drive. This is the one I built, called the Cobra. But any stepper drive could work. However, I would recommend you don't use one of the cheaper ones, like from China, because they're not well tested and they have a lot of issues. If you use one of those drives, I would suggest solder directly to the stepper motor wires. Don't use the connector, because that connector can fail. But this drive is running at 2,000 counts per rev, and the step-in direction comes between here and here, off the controller into here, and here I've got the analog inputs for the dials, the two dials, power, and it can also data log out to a laptop, displaying continuous pressure and time. So that'll be something that's an accessory. You know, you don't have to use it. It doesn't have to connect to the laptop. The way I've got it is so easy to operate. You turn it on, and it starts to run. Okay. Now, the way I've got it is it's so easy to operate. You just turn it on. It goes up high, and then it starts to run. Now, if it does hammer, it'll find its center. You can see the air bubbling out there. But so I mean, you could use an Arduino if you want. There's Arduino PIC. There's no point worrying about which is which. Whatever you got. I'm a PIC I know I've used PICs for over 20 years, so that's what I know. That's all the programs I have are for PICs. But if you want to do it in Arduino, that's fine. You know, it doesn't make any difference. This is just an 8-bit processor, so it'd be similar to the Arduino 8-bit processor. That's all you need. I'll post this week. I'll post the software flow chart and how simple it is to write it. Now in here I have a pressure sensor board. Now it's just sitting in there right now. Actually, I haven't bolted it down, but I'm still working on that because I don't have the right pressure sensor. This is a high pressure one. Actually, I used to build turbo boost controllers. About 50 when the Fast and the Furious phase was on, I was into turboing. So anyway, that's more of a 30 psi boost one, but it doesn't read. Now we're running here under 2 psi at the max. I think it's 3/4 of a psi to push up your lungs. It might even be a lot less than that. I'm not a doctor, but I do know electronics and motion control. That's what I'm a doctor of. So, I've been building CNC routers for 30 years, Larken automation. This is my System 60. I cut the first puck on the System 60, but I also have a V40 lead well machining center over there that I do everything on. So I'm pretty well equipped here. I also have lathes, mills. I have a small shop. I can build these machines, but mostly these, I could build them, or I can build them, or I will build them. But I'm also encouraging other people in other countries that you can build ventilators. If you have some young kids that know a bit about automation, electronics, I can help you out. You can email me or contact me, and I can help you out build these, because there is a rush. We can't wait weeks for machines to be developed by big companies, because that's going to take weeks and months. We can do it if we have the right to save a few lives. That's what it's all about. There's no way we can compete with a big, massive countries like China in production. But if we can save a few lives, that's all we're trying to do here. So if you need any help or advice to build one of these machines, you can contact me at larken@storm.ca. I'm in Ottawa, Canada here, in Ontario, and we have a fair number of cases in Canada as well. Huge number of cases in the US, in New York City area right now, and it's just exponential. So anything anybody can do, there's going to be a shortage of ventilators very soon, and there already is, and it's possible you might be able to help. So anyway, take care and wear a face mask, whether they tell you to or not. Wear something over your face.